Good afternoon, everybody. Welcome to Stage C. In case you're not aware, the Wi-Fi is up and running. All the information's in your packs. I think it's EMF Camp and EMF. It's my pleasure. As you can see, the screen's a bit dark. There aren't any slideshows for this one. We are trying to improve it for later. You'll notice when we've got better screens because suddenly you'll be able to see them in daylight. Otherwise, it'll all be fine tonight. It's my pleasure to introduce, for this talk though, Tom Oinn on Basebots.
Screaming fans, excellent. Do I need this thing or shall I shout? Okay, right. So thank you. Here is my extremely poorly planned and prepared quarter of an hour talk. I have no slides, so it's actually turned out to be a good thing. But honestly, the reason I have no slides is I only actually finished making the hardware for this at 2:30 this morning. And so I've had no sleep, a little caffeine, and am inclined to ramble and talk too fast at the best of times. So if I'm totally incomprehensible, can you please just heckle loudly, and I might notice and slow down. So, I'm Tom, so thank you for the introduction, and well, thank you to EMF in general. I'm nominally affiliated with Cambridge Makespace, so I'm just a member there, and so this little thing was made there. You should come and drop in if you're in around the city, or in fact drop into our village. It's over there somewhere. It's on the map. The Basebot is an attempt to make simple electronic projects mobile. So if you've done any of this, what you might call physical computing, so rather than writing things on the screen and making things light up on your VDU, you actually have some interaction with the physical world. You'll notice that, for one thing, people find it much more interesting. If you ever teach this, the amount of entertainment even totally normal adults get out of turning an LED on is utterly insane. I don't know quite why this happens. It's because of some exerting control over your environment or something like that. But if you're going to teach someone programming, or you get someone excited about programming, whether that's a 5-year-old or a 50-year-old, one of the best ways to do it is to make something that interacts with the real world around you. A follow-on from that, so I typically use Arduinos because they are incredibly cheap. The obvious other case is the Raspberry Pi, the MicroPython, and any number of other microcontroller boards. You plug together, you wire them, you break a few, it doesn't really matter because they only cost £5, and so on. And at some point, you might start thinking, well, the two things people want to do, they want to get their projects networked, which is one aspect, and I'm not going to talk about that, and they want to make them move. It turns out that making your project move is actually really hard. Not because motors are particularly esoteric pieces of kit, or that batteries don't exist or are expensive or anything, but because the moment something has mechanical parts that have to rotate, you have a whole load of things you have to take into account, design tolerances, is it going to stick? How do you actually make it physically? So, this little guy, which is not actually a very impressive demo, I'm afraid, because it's running test firmware, but this is a Basebot. So, what I have here is the Basebot chassis and the motors and the battery pack, and in addition, an Arduino Uno and a Pixie camera vision processing module from Carnegie, which was a Kickstarter a while ago. These little things are great because they, as an aside, they offload all of the heavy image processing lifting that you'd have to do otherwise. If you've ever contemplated doing image processing on an Arduino, you'll realize very quickly it simply isn't possible. They don't have any power, they don't have any memory, and the moment you start going, well, can we process a frame buffer 50 times a second, the answer comes back very quickly, no. No, you can't do that. So this little thing, which I recommend buying, they're about $35 or something, will spit out a list of bounding boxes of features it finds, and your Arduino definitely can handle that at 50 frames a second. So this actually won't, I'll be able to show you this as a proper demo if you drop by the Makespace tent later. I'm not going to try and do it now, partly because it doesn't have the right firmware actually loaded into the microcontroller. But the premise is that other than the Arduino and the camera, this is what you get if you make a Basebot. So this is all open source. All of the schematics for it are on GitHub. It's not as well documented as it should be. Shock. An open source project not documented well. I can see your looks of utter amazement at this point. This is version 16. If you're contemplating designing a machine and using a 3D printer or a laser cutter to build it, be prepared for lots of iterations and a lot more time than you expected. I seriously thought this was going to be, a couple of afternoons of playing around and wire some motors in. There are some minor tweaks, but this is pretty much the finished article. Now, it takes about half an hour to cut all the parts of one of these on a laser. So we have an HPC laser thing that's about the size of a small grand piano in MakeSpace, and it's one of the more powerful ones. It still takes half an hour to cut, mostly because of all the holes. That may or may not have been a good design decision, but it's really handy when it comes to mounting things. And that's really the point of this design. It's the bare minimum you need to make your project mobile. It's agnostic to microcontrollers. It provides a large number of mounting points for other hardware. So in this case, I've put a camera on it. Maybe you have ultrasonic rangefinders, maybe GPS, magnetometer, temperature sensors. So one of my test applications for this would be, can you make something that will navigate autonomously around a room, take temperature readings, and tweet them so that software on a server can build up a temperature map of your space, for example? It's the sort of thing you could only do once you can make your project mobile. Simply wouldn't be possible otherwise. Speaking of mobile, we could be all about to go on a magical mystery adventure in approximately that direction. If it happens, please try to keep the screaming to a minimum. I have a headache. So to be honest, that is actually the salient point. The Basebot is not complicated. What it is a set of laser-cut platters. It uses continuous rotation servos, and the advantage of these are you don't have to worry about power electronics. Typically, if you take, say, a 6 or 12 volt motor and you want to interface it to a microcontroller, you have to go through some intermediary. You can't simply plug the motor into an output pin of your microcontroller. It will either fry it or not work, or both. Most probably both, if you're unlucky. So typically you use what's called an H-bridge, or a specific motor driver chip with a heatsink, and that's another thing you have to mount and source. And you can get these things from eBay, dirt cheap from the Far East, but are you going to be able to get them, say, next week? You don't know. A servo, of course, traditionally would be a rotating armature that moves between a range depending on the pulse width that you feed it. But the key point is that the input to it is digital. And it's a logic level digital specifically. So you provide power to the servo, but then your microcontroller can talk directly to it. There's no other circuitry required. So when I say that all you have to add to the Basebot is a microcontroller, I do literally mean that. It's got the power conditioning, it's got the motors. Typical cost to build one, well, it's going to depend on what battery you pick. This is a nickel metal hydride pack. It's using reasonably nice continuous rotation servos, and this version probably is about £35. If you go all out on saving costs, you can probably pull that down to 25. So it's getting to the point where for a class, you could give it to children rather than having it as something only the teacher gets to talk at. For those interested in swarm robotics, which I am, personally, for one thing, I can, if this is new to you, I thoroughly recommend looking on Coursera for the control theory course from Georgia Tech, where they will do, amongst other things, show you how to do puzzle solving across 12 robots. Of course, for that, you need 12 robots, and if you go and buy commercial ones, then suddenly you need to sell your car. If you build these, okay, 12 of these will cost you a fair bit, but not that much. If you're a hackspace, you can certainly make 12 of them. It's never going to be zero cost, but it's going to be as cheap as possible, and that's the general idea of this. So, it has a website. It has a blog, which I don't post to nearly enough. It has a Twitter account, because everything has a Twitter account. And it has a wiki, and the wiki is currently deserted in a barren wasteland of emptiness, which is sad. What I'm hoping to get from being here at EMF, as well as the random drunken conversations at 2 in the morning with crazy Dutch people who I happen to have camped next to by accident, and discovering new cocktails and accidentally electrocuting myself in the retro gaming tent again, is to find some people who might be interested in taking this to the next stage. So there are really two problems that need solving. One of which is production and distribution. At the moment, you can't buy one of these things. You could go and buy the parts, you could go and cut the platters on a laser, but I'm not getting into the business of producing this. I already have a day job which is taking about 800% of my time. I play 6 instruments, and yeah, I don't have time to create another company that won't work. Done that twice. However, if we have some, I know that Phenoptics are lurking around somewhere. I don't wouldn't recognize them visually, so maybe here. Any small companies that can laser cut parts and sell them on at some approximation cost would be fantastic. But the other thing is content. I'm happy hacking with this and picking up my random modules I bought from China and chucking them with an Arduino and things. But it would be great if we could develop some lesson plans at one extreme or just kind of general guidelines at the other. The activity range we reckon for this varies from 6-year-olds where you build a shell and you paint it. You can decorate, so you've got the kind of artistic elements of that, right up to degree level control theory and swarm robotics and collaborative applications with quite advanced sensing. I mean, this itself is none of those things. It's a platform you can build on, but it could be. What's missing now is the content that is necessity. If you're a teacher and you say, well, great, this looks fantastic, what do I do with my class? At the moment, there's this big hole. And you go like, well, you could build some, and then that's quite interesting in itself in some ways. But then, okay, well, what problems do you solve with them? What do you do? What are you trying to teach? What level is appropriate to what? I'm not a teacher. I'm an ex-academic, I'm a freelance software engineer, I'm a general tinkerer and hacker, but one thing I don't know how to do is teach 8-year-olds. Someone who actually teaches 8-year-olds regularly, they'd probably be in a better position to do this than I am. So that empty wiki of desolation and loneliness, I would absolutely love for that to be populated with people with interesting ideas. We can make sure that anyone who wants to do this gets a Basebot at some nominal cost to cover the parts. We can cut the laser bits, no problem. So yeah, just kind of got some more people on board at this point. It works. At the moment, all it will do is run across the stage and fall off, but I can get it to do that. Just to show you it's not actually totally faked. It's reasonably quick, and it will actually. So it's quite tough. If it actually has enough traction, it would happily run over that cable there, for example. It runs on short grass, which I didn't expect. One of the other aspects, of course, of it being a laser cut design is you're designing in 2 dimensions. That's a lot easier than designing in 3. So if someone can find a laser cutter, and I believe there are some around here, download the DXF files for this, or Inkscape SVG, and modify the wheel so it's a toothed wheel rather than one with a plumber's O-ring on. Incidentally, plumber's O-rings, packs of 20 for about £4. Model car tyres, packs of 2 for about 10. There's a reason I'm using O-rings. Yeah, and the casters are from Bulgaria. I don't know. Like, if you can find somewhere that isn't Bulgaria to buy very small casters, talk to me. I don't know why they come from there. They just do. Yeah, so have a play. I've got the parts, which I cut at, as I said, 2:30 this morning, to make another 2 of these in a highly fetching purple and a rather unpleasant orange colour. Apologies to our Dutch friends. If you would like to help make these, program them, hack them, have a play, drop along to the Makespace tent. I can't guarantee that I'll be there at any given point, but someone there will be able to find me. So yeah, thank you for coming. How are we time-wise? Any questions? That man I definitely don't know and haven't planned to answer questions. I could if I brought my laptop, because at the moment the firmware in that is just to test the motors, and so it just runs them full power forwards. I will put the firmware back on that I used for the demo at the Cambridge Science Centre the other day, where I taught it to follow people's shoes by colour. So there's video up on, if you navigate the links appropriately. Oh, sorry, I should have said, the website is basebot.org. Should hopefully be findable, and everything's linked from there. Yes, we had it chasing this little girl was very taken by it because the camera does color recognition, so she had particularly unpleasant pink Crocs on, so the robot was chasing her around the room in quite a sedate fashion, but and because it was running an incredibly naive control algorithm, it was jittering around all over the place. No PID stuff in there. But, yeah. Yeah, sure. Let's have a look. I haven't tested that, but it is pretty solid. The intent was to make something that went a bit over and beyond the very basic kits you can get, because, I mean, it's a fairly crowded space, 2-wheel robots with casters, right? Most of them, however, are either much more expensive or they're very hard to customize. So this was always intended that you could mount a lot of kit on it. I actually mean to meet up with the Phenoptics guys because they have a robot arm kit, which again is laser cut acrylic, and which should fit perfectly on the front of this. So that could be quite fun. I mean, it depends a bit on the motors you pick, because there's continuous rotation servos aren't all equal in terms of their power and their torque. These particular ones are factory, so they're not hacked ones. I've got ones which I got from eBay, which are Tower Pro MG95s or something, which have been hacked. They are really high torque. They drift. Because it's a hack, they're not actually that great. But when they're running, they will drive that thing. I mean, you can't stop it. You can push it down so it spins its wheels, but you can't stop them actually moving. I reckon yeah. I mean, some kilos. I don't. Well, that particular battery is. Oh, just a second, I have another one lying around somewhere. Yeah, so I rather doubt that those motors are drawing more than an amp between them. So, I mean, 1.5 hours, basically. I mean, obviously you've got to drive the electronics, but that's a relatively low current application. These packs are reasonably expensive. They're one of the parts that I would swap out. What I'd actually suggest people used were 6 packs of AA NIMH cells. So the NIMH rather than lithium polymer, because they're much more tolerant to damage and abuse. So if you're talking about something that you're going to give to kids, having a battery technology that has a tendency to explode if maltreated is bad. These things, you can discharge them, you can trickle charge them, it doesn't matter. They're more expensive, they're heavier, and they're less good, but they have desirable properties. But you could run this off regular AA cells. I mean, it's nothing particularly esoteric about it. I just like these because they're rechargeable and they're small. Yeah, so it includes so if you have a look at it, there's quite a lot of things, like there are metal spacers to hold it. So it's one of the reasons it's a strong design. 3mm acrylic is intrinsically very strong. It's sandwiched, so it's basically braced with hex PCB spacers and an M3 hardware to link those together. The spacers are actually one of the more expensive parts. You could try and replace those with something flimsier, but it would be a flimsier design. The cheapest I've seen the continuous rotation servos are about $4. These ones are more like 12. The batteries, this I think was £12, and you could clearly do a lot less than that. So, yeah, the figure I quoted was for that one. I reckon you could get it down to about 25 quid, especially if you're buying in large numbers. So I'm not selling it at all at the moment. As I said, your best bet is to find a friendly laser cutter equipped hackspace, or so. What I'm hoping, I mean, my ideal outcome would be that someone turns up and goes, "Hey, we've got an existing business where we sell laser cut parts. We'll sell these for you." I mean, you can go to GitHub and get the SVG files. So what you end up with. This is the number of parts for 2 of them. So it's quite a lot. I mean. Bag of various smaller bits, the top color mounts and the platters. So that's a pair. This is why it takes a while to cut. But, yeah, I mean, obviously separate out by color, and the white parts will make 2. But the yeah. Sorry, You certainly could. I mean, you could clearly make your own spacers, but it's actually quite fiddly. I mean, it will take you a while to make 20, 30mm spacers. I mean, if you have a pillar drill and you make a rig for it and you tap them, yeah, you could clearly do it. They're not so expensive that it bothered me, and also by making them out of metal, it makes it much more robust for being dismantled and put back together again. I think we've got the hours of time by masses, but come and talk to us at Makespace, Cambridge Makespace. We're on the map, so. Sorry for overrunning, and yeah, thank you again for coming.